Microservices versus monolithic architectures. Contents. Monolithic architecture, microservices architecture, scalability, deployment, maintainability, conclusion. So this is the monolithic architecture, which includes layered uh, presentation. First comes presentation layer, then service layer, then persistence layer, and then it is connected to the database. So monolithic architecture is a traditional software development approach where all components of an application are combined into a single unit. This architecture is categorized by the presence of a single large code base that is tightly coupled and difficult to maintain. Monolithic applications are usually built using single language and framework, making them highly dependent on underlying technology stack. This makes it difficult to scale and deploy as any change to the code base requires entire application to be redeployed. Monolithic architecture is a software design pattern where an application is built as single autonomous unit. In this approach, all components of the system are tightly integrated and built into a single executable file, making it difficult to change or scale individual components without affecting the entire system. This type of architecture is often simpler to develop and maintain in the short term, but can become cumbersome and hard to manage as the application grows in size and complexity. In monolithic architecture, adding new feature or fixing bugs is one part of the system and can require an entire application to be redeployed and restarted. Overall, monolithic architecture works well for small to medium sized applications, but is less suitable for large, complex systems or for organization with rapidly changing requirements. Application. Monolithic applications are software systems designed using monolithic architecture where all components are tightly integrated and built as single autonomous unit. In monolithic application, all functionality is housed in a single code base and the application is deployed as single unit. This type of architecture is often simpler to develop and maintain in short term, but can become difficult to manage as the application grows and evolves over time. Monolithic applications can be deployed on single server or multiple servers, but deployment process is typically more straightforward compared to microservices applications. However, updating or scaling individual components can be challenging and often requires the entire application to be redeployed. Monolithic applications are often used for small to medium sized systems for organizations with stable requirement, but may not be the best choice for large complex systems for organization with rapidly changing requirements. Advantages. Monolithic architectures has several advantages that include simplicity. Monolithic architecture is a simple to develop and deploy as all of the components of the system are combined into a single code base. Easy to test. Monolithic is architecture is easy to test as all the components of the system are combined into a single entity, making it easy to perform in end-to-end testing. Lower cost. This architecture can be less expensive to develop and deploy as it requires fewer resources and less complex infrastructure. Familiarity. This architecture is familiar to many developers and organizations as it has been used for many years and is well understood. Easier to coordinate. This architecture can be easier to coordinate as all the components of the system are combined into single entity, making it easier to coordinate development and deployment. Overall, the monolithic architecture has several disadvantages, including limited scalability. It also has several advantages, including simplicity, ease of testing, low and lower cost. It can be an appropriate choice for smaller and less complex applications. Disadvantages. Monolithic architecture has several disadvantages that includes rigidity. Monolithic architectures can be difficult to change and modify, as updated to one part of the system can affect the entire system. Slow development cycles. This architecture can lead to develop slow development cycles, as the entire system must be rebuilt and deployed for each update. Monolithic architecture can be difficult to scale, as the entire system must be deployed on single server and must be scaled as single entity. Single point of failure. Monolithic architecture can be vulnerable to a single point of failure, as a failure in one part of the system can affect the entire system. Lack of agility. Monolithic architectures can be less agile than microservices architecture, as updated to one part of the system can affect the entire system. Difficult to maintain. Monolithic architectures can be more difficult to maintain, as the entire system must be updated and maintained as a single entity. Efficient resource utilization. Monolithic architecture can lead to inefficient resource utilization, as resources are not optimized for each component of the system. Overall, while monolithic architecture can be simple to develop and deploy, it has several disadvantages, including rigidity, slow development cycles, limited scalability, and lack of agility. This is the architecture of microservice. So, which in as you can see in the diagram. So, moving on to the microservices architecture. Microservices architecture is a modern software development approach that focuses on building application as a collection of independent services. Each service is responsible for single task and can be deployed and managed independently of other services. This architecture is categorized by presence of multiple small code bases that are loosely coupled and easy to maintain. Microservices are usually built using different languages and frameworks, making them more flexible and easier to scale and deploy. Microservice architecture is a software design pattern where large application is broken down into smaller independent services that communicate with each other through APIs. In this approach, each microservice is responsible for a specific business capability and can be uh, developed, deployed, and scaled independently without affecting the rest of the system. Microservice architecture enables the organization to build and maintain complex applications more easily and efficiently, as the separate services can be managed and updated independently. This makes it possible to update one part of the system without having to redeploy the entire application, leading to faster development cycles and reduced downtime. In addition, microservices architecture can improve scalability and resilience, as services can deploy across multiple servers and easily replicate to handle increasing traffic. However, developing and maintaining microservices can be more complex compared to monolithic architecture, as coordination between services is necessary and there is additional overhead related to communication between services. Overall, microservices architecture is a good choice for large, complex applications and for organization with rapidly changing requirements, but may not be the best choice for small to medium sized systems or for organizations with stable requirement. Application. Microservices application are microservices application are software system designed using microservices architecture pattern, where a large application is broken down into smaller independent services that communicate with each other through APIs. In microservices architecture application, each microservice is responsible for specific business capability and can be deployed, developed, and scaled independently. This approach enables organizations to build and maintain complex applications more easily and efficiently, as the separate service can be managed and updated independently. Microservice architecture applications are well suited for organizations with rapidly changing requirements, as new feature or updates can be developed and deployed for individual services without affecting the entire system. This leads to faster development cycles and reduced downtime. In addition, microservice architecture's application can be more scalable and resilient compared to monolithic application, as the service can be deployed across multiple servers and easily replicated to handle increasing traffic. Examples of microservice architecture application include Netflix, Amazon, and Uber among the others. Advantages. Architecture has several advantages that include scalability. Microservices can be deployed and scaled independently, allowing the organizations to respond more quickly to changing demands and handle increasing traffic. Resilience. Microservice architecture can improve resilience of application, as services can be deployed across multiple servers and easily replicate to handle failures. Faster development cycles. This architecture enables the organization to develop and deploy new features or update more quickly, as each service can be updated and deployed independently. Improved maintainability. This architecture makes it easy i- to maintain and update complex application, as each service can be managed and updated independently. Better product innovation. Microservices architecture enable an organization to experiment with new technologies and product innovations, as the services can be developed and deployed independently. Easier integration. This architecture makes it easier to integrate new technologies and third party services into the application, as service can be developed and deployed independently. Better utilization of resources. Microservices allow organizations to utilize resources more effectively, as each service can be deployed on the most appropriate infrastructure. Overall, microservice architecture can offer many benefits to organizations, including improved scalability, resilience, and faster development cycles. However, it also introduces new challenges that require a different approach to development, testing, and deployment. Disadvantages. Microservice architecture has disadvantages that include complexity. Microservices architecture adds a level of complexity to the development process, as coordination between services is necessary and there is additional overhead related to communication between services. Testing and deployment. Testing and deployment microservices can be more challenging compared to monolithic applications. Each service needs to be tested and deployed individually. Data consistency. Ensuring the data consistency across service can be challenged, as each service has its own database and there is a potential for data to become consistent or out of sync. Inter-service communication. Communication between services can add latency and increase risk of failure, as each service may rely on APIs to communicate with each other. Debugging and troubleshooting. Debugging and troubleshooting microservices application can be more difficult as issues can arise from interaction between services and can be challenging to identify source of a problem. Increased operational overhead. Microservice architecture requires more complex operational environment with additional infrastructure and tooling required to manage and monitor individual services. Overall, while microservices architecture offer many benefits, it also introduces new challenges and requires a different approach to development, testing, and deployment. Scalability. Monolithic applications are difficult to scale as any change to code base requires entire application to be redeployed. Microservices, on the other hand, are easy to scale as each service can be deployed and managed independently on the other services. Microservices also offer more flexibility in terms of scaling as services can be scaled up or down as needed, whereas monolithic applications require the entire application to be scaled in order to accommodate changes in demand. Deployment. Monolithic applications are difficult to deploy as any change to code base require entire application to be redeployed. Microservices, on the other hand, are easier to deploy and each service can be deployed and managed independently of the other services. Microservices also offer more flexibility in terms of deployment as services can be deployed to different environment as needed, whereas monolithic applications require entire application to be deployed in order to accommodate changes in demand. Maintainability. Monolithic applications are difficult to maintain as any changes to the code base require the entire application to be redeployed. Microservices, on the other hand, are easier to maintain as each service can be deployed and managed independently of other services. Microservices also offer more flexibility in terms of maintainability as services can be updated as needed, whereas monolithic applications require entire application to be updated in order to accommodate changes in demand. Conclusion. Monolithic architecture is a traditional software development approach that is characterized by presence of a single large code base that is tightly coupled and difficult to maintain. Microservices architecture is a modern software development approach that focuses on building applications as a collection of independent services. Microservices offer more flexibility in terms of scalability, deployment, and maintainability, making them better choice for modern applications that require frequent updates and changes. Thank you.